Now we are going to speak on standards for solving inventive problems and their development. I'm going to start off with the history, how it all started, and you know that one of my visits when I went to Alcala's office in his apartment, we discussed together, and it was one of the laboratory Almi group discussion, and it was dedicated to such a topic, how standards can look like. And the general idea of standards belonged to Alcala, and he asked questions. What is basically standard? How shall it look like? And so we had a dialogue between Mr. Gorin and between Mr. Alcala. He was a well-known athlete. He went into climbing, and Gorin has such an idea that standard that means just to jump in the right direction to some basic camp, and then one gets back and follows the Aries steps. And Alcala has his own radical position that the standard shall give without Aries the solution of the highest level. This is what he highlighted. Here you see a picture of the apartments, the first floor, very green, and Alcala took care of these plants, and you know it made sense because it's so green on the balcony of Mr. Alcala. And with these plants, the standards was developing, and they are the major principles. And yeah, you're absolutely right. Anderson forgot that he was the chief editor of the Voice, and he wrote a book. It was called as The Long Tales. I do apologize. Valerie, do you speak to us? It was about the generation of the products. Mikhail, could you please mute yourself? Thank you. Right. On the screen, you see the major standards, and I'm going to name them. First of all, they are weight tasks. This is not a narrow direction. The solution, they it also shall be quite general. They shall be of the high level. This is what additional highlights it. Then the standards, the development of the techniques. Each standard has a combination of techniques and effects. So that means that Altula, and we were speaking about that today, that's the future of the principles. They are standards and bipolarly. Then the formulas of the standards, unlike the techniques, contain description of generalized problem tasks. It's important because any principle, to which task does it belong? Standard contains the modules of the task which we solve. And for standards, it does not require the utilization of arrays, and standards are able to eliminate invention. And Alcala said it back then that standards are able to eliminate invention as a creative activity and transfer it to the category of engineering design and development of technical system. Any specialist in design, it takes a couple of minutes, and with the help of standards can see advantages and disadvantages. This is the concept of Alcala, which is still topical even today. And now about the history of the formation, we can divide it into two stages. The ones which were formed in the 20th century and the ones which we tried to apply in the 21st century. In 2010, we started to develop this topic. Now, the Ellerfield, Vipole, the system of bipolar in 85 typical conflict schemes we're going to show you. 86, the algorithm of application of standards, because there are many of them and there are different options how to apply them. And I will show you later how we united it, how we unified that. And then, after Vipol, we moved to Alifield. They are universal structures. They're not only about engineering systems, they're also about the finances. Then there was the universal standard system, and we presented in 2010. There was the combinatorics. It is a necessary tool to develop the standards. The system of B poly, Alexander was talking about that. And then we proposed the complex of standards, and I'm going to speak more about that later. We tried to understand what was the difference between the trees in the 20th century and the 21st century, but some of the aspects. The general is that there are the logics and the laws of dialectics and different scientific approaches. This is what was the foundation of Alcala. And this is about the higher level of inventions, etc. And what is the difference? Well, first of all, is a well-known trend that technical tasks are moving into other fields. Not only strong minds, but also weak meaning have they for industrial facilities and for business in general. And this is also very typical of different presentations, and you heard there. Moreover, the application of computer and artificial intelligence, and they are just the minor things which I can say, and they're typical of the 21st century. If we speak of the comprehensive standards, the prehistory, in this slide, you see it here, and I'm going to repeat it to you. We speak of the alley-pole analysis, element field analysis, and they influence the system. And there are 76 standards. There are lines of system development, and there were the universal system of standards. So this system is getting more comprehensive, and now they move to the program complexes as the major parts of the mechanical work, if I may call it this way. Now this work is performed by computer and by the program. There were bipolies, and we're going to show you how the analysis is used in the comprehensive standards. The comprehensive standards, why are they called this way? Because they consist of three directions: bipolar principles without matrix, universal standards in their application, and domain. And this is about the functional analysis, and it is about the standard problematic situation. I'm not going to speak on bipolar principles because we have already heard in today's webinar Alexander's presentation. There are 18 bipolar principles. Every principle has its correlation with 50 principles, and we included not 40 but 50 of them, the basic ones and the additional ones. It gave us an opportunity, and we can divide them, and we can develop new one if there are going to be new principles. There are the ones which you know in the business, and we covered some of them today. They can get developed and they can include new approaches. And very briefly about these tools and how they are differentiated, the transition from the pole to early pole. There are other approaches in the standards. There are different structures in the analysis, and they are might be different, and the other fields or the system, they are closed. They are based on cycles. There are rather different types of structures. Here we see some developments, and it is not only about the techniques, but it is also about more difficult structures. From standards to universal standards. What do we mean here? If we are going to try to systemize the standards, which was systemized by Altshuler, and I shall remind you that Igor had to be today with me because this was our mutual effort, so to transfer this system. It is some other fields is quite difficult in terms of structure. Then, maybe it is more important. We found out that standards 76, they are not so logical, and they're based on dipole structures, and some of them they do not have a field structure, and they might have different lines of development or different effects. And in order to get the structure for the standards, it was suggested to divide the difference and to divide them in accordance with the lines of development, and then in every single structure we can use different lines of development. And the lines of development might be generally systematic for every system, and for business, for engineering, they might be all different, and for some other fields. And this system became more structured, and it allowed the lines of development and the standards and the system of standards, they do not change its structure. Synthesis and some different types of structural approaches and the lines of development which we know, dynamization and the lines of development, There are certain lines of business, price formation, and the other. And this system was proposed in 2010 as the Universal System of Standards. Another important thing was to create the algorithm for using standards. I believe it was in 1986. And despite the fact that this algorithm is not a simple one, it simplifies the work with standards and it allowed to structurize the work and the universal system of standards. It also proposed such an algorithm by Oleg Gerasimov. He provided with some of the examples. It is more simple because the system itself is more simple. And you see that it also takes into consideration different skills. Then these algorithms they were transferred to the software combinatories and there was a switch, a move from the paper documents, paperwork to the software workflow. And this is an important part. And this is what we added to the standards. And it was also developed by Alchala. The partners of typical conflicts, they appeared in Aries, and it seems strange probably. In the course of these years, the set of the typical conflicts, it was not changed. And this is how Alchala prepared that, and this is how they looks like now. I'm not going to speak more about that in a very detailed way. And we see here the complex of actions of different types, that there are incompatible actions, for example, to useful actions, but they cannot be implemented. Incomplete, insufficient action, silence, or unregulated action. They are typical conflicts proposed by Alchala. There was the idea to unify these typical complex patterns with the standards, with standard approaches to the task solving, and they are now known and traced. And the system which you see in the first column, they are typical model, and I'm going to try to build this connection with the analysis, the combinatorics program. Automatically, it recognizes the type of conflict based on the functional model. And when the functional model is identified, then there are typical bipolar methods, typical standards, and trimming as the universal mechanism as the target for any, as far as I know, as far as I managed to find out, in every type of conflict, it is in different instruments. Let me repeat to you once again. The complex of standards, once again, is based on the typical conflicts and the models or the solution, bipolar methods, standards, and trimming. I have requests to Alexander. Would you please tell me when I have to stop?
Да, конечно.
Because our time is limited? Yes, sure. How much time do I have? Before Q&A, you have still 20 minutes. Okay, thank you. Great. I'm going to give you a couple of examples, and they are very typical and classical tasks, and I'm not going to explain to you everything in details. This is a task about the parachute, about the test in the transparent glass tube where they add and pump water, and there is some paints, and from these paints there are some like eddies. They're not visible, and these swirls are created from some objects. And there was the problem that if this paint is a very thin layer, the everything is remains the same. The dimensions of the layouts is not distorted. However, the paints you will have the paint shortage very quickly, and you need to create a new layout. Otherwise, if you have a thick layer, it is also not so good, and it can lead to some negative swirls, not correct, incorrect swirls. But you probably know about this task anyway. What I would like to tell you now, there is the model of the problem. Here you see water. Water performs very useful function. It creates swirls, but at the same time, the water blurs the paint as the paint colors the swirls, and the paints can negatively affect the shape of the layout of the parachute. And the layouts, the mock-up of the parachute creates these swirls, and automatically the system defines that here there is both a good and negative connection. This is a typical conflict, and as I've just mentioned, it was resolved in three directions: principles, trimming, and outfields. The standards for outfields, and I'm going to speak more later about that. So for every type of the conflict, there were bi-poly principles. Usually we use these particular option, and after moving to one or another principle, here you can see both solutions and tips. If you see the tips are very clear to one another, for example, to use some emptiness, and in the description it is stated that this is what can be applied, and what I do apologize, what can create with the help of chemistry or electrolysis or some other means. And then these bubbles, they remain there, and you don't need pain. And the change of the chemical parameters is also an assistant, a principle, which can be used to solve different tasks. Here you see the same slide in English, and by the way, the combinatorics, it has the opportunity to be in three languages: Russian, English, and Chinese. We decided to have a look to which extent the recommendation of the standards is in line with the ultra metrics. And here there is this comparison. And I would like to stop here and to tell you more. Let me remind you, here we were speaking of the principle 14, 17, the bipolar principles, and here these two principles, they are now standards, application of voids and porous material, and changing physical chemical parameters and phase transitions. Then you see the matrix of Alchula, shape and material laws. I believe that they resemble to one another. This is the contradiction. And in accordance with this matrix, we have the application of voids, the changing of physical chemical parameters, and this is in line with what was in the standards. And in the matrix, we also went out to dissociation and association, fragmentation and combination, because they are by poly principles. There are is a set of them, like they are connected with a dissociation.
I would think that this is a very good way to have both of these, a good combination. Some people maybe not are not accustomed to bipoly, but in Campino trees it's possible to use any you prefer. You can use a classic table or bipoly or business variants or other forms. Many matrices are available here. We So we looked how the same problem can look like in different matrices. We used the methodology of Altshuler, and we also have those constructs, and again using the empty and change of physical-chemical parameters of the object is another option which we used with bipoly principles. In my opinion, we have this very clear correlation of applying principles without the matrix with the same results, more or less the same results. The next area for the comprehensive standards is those universal standards themselves. Here you have them. And software actually hints at the type of a problem and the task, and it also hints at those elements that need to be changed, adjusted, what kind of fields we need to add, and we also use the development line in this area, so you can use different development lines, so you can select a line which you want. This standard is related to the introduction of elements. We have three elements in different forms, so we can remove this harmful link, and it is possible to do that by means of adding this element to the product, adding it to the product or to the tool. There are different options available, different ways to do that. Here, maybe we need to add an element, but maybe we shouldn't do that. So we add a paint, and then it created more issues for us. So now we look at what kind of those development lines are hinting at, and they are hinting at emptiness. So having this emptiness here and using it, and there is a description there. We also have other pop-ups of other hints or tips, typical substances. If there is emptiness in affects, so it's possible maybe to use other approaches, such as electrolysis. So this is how it looks like in Campino trees and how it is implemented with those standards approaches with development lines. This is how it works in Campino trees. Development lines in Campino trees. Here I would like to just give you two examples of two development lines. A line of administration of substance, porous materials modification, then followed by filled external additive. This are this line here, you can see it. So these are typical substances. And here you have the tip popping up on what to input. If we put a mouse pointer to a specific field, there is a pop-up hinting at its function. So this line is looks really logical, so it has its own logic. In practice, on the other hand, so I and Valery Sushkov, we had this discussion, and we have had this discussion today. So in practice, it might look like when you have a problem having this external additive or this emptiness which worked best here for the development line. So you need to go through this line, go along this line end to end, and see those pop-ups and select the best one, the best fitting for the current problem. It's always different. Uh, it always changes. Here we have this typical fields, and this shows this line, which is the line of identifying measurement detection, information acquisition. So this is the line we have here, and we also are going to add other lines of development in Campino trees. Like Lee will speak about it tomorrow in more detail. This third area, which is trimming, when there is one variant here when we don't have a paint and having another element performing its function. Here we have air performing this function. So before we saw this hinting at emptiness, here we have a different one. So this is an element hinted by the trimming method, the trimming principle. So instead of that, it is hinting at air or bubbles that can be used in such a way, or some other renewable ways to visualize the vortex. The next example is about the problem of arc welding. So we specifically selected this example. This is just to exemplify the conflict when we have two valuable functions, two good functions, but it's not possible to implement both of them at the same time. For the standards of this type, we didn't have a conflict, and that's why we had to formulate it for this specific conflict type. A few words about the problem itself. So we have a known method. There is a known method for studying the arc welding process using an additional illuminator. With such additional illumination, along with improving the visibility of solid and liquid material located in the arc region, the visibility of the plasma gas phase of the arc column deteriorates. It is necessary to propose a method in which both the plasma of the arc and the metal around its arc are visible. Both are visible. So when we put some light there, so we see one, the first one. If we put light on the other one, we don't see other elements of the process. So these valuable functions, we wanted them to work simultaneously. Looking at the scheme for this type of conflict, that we use these two valuable functions, and these functions could not be performed at the same time simultaneously. So we took it from Altschuler's schemes of typical conflicts, additional illuminator, which illuminates metal, and then it informs the observer. Welding arc column again informs the observer, but we cannot have both these functions functioning simultaneously. It is either of them which function. Here we have this Campino tree suggestions, and there are a few models to implement this. We also have this line of development. Now, this line of development I have already mentioned and talked about it. These models here for addressing the problem, for solving the problem, are related to unifying or combining elements. And in such a setting, we should work with the dedicated line of development. Those are the techniques or methods, continuous or periodic useful action or dynamization. So we go from continuous action to dynamic action. So this impulse action, or when we have bright illumination and then we don't have it. So this is the same with the eye. When we watch a movie, when we watch a film with those frames changing before our eyes, so we watch a film and see it as a continuous action. So we want this also to be switched from continuous action to periodic action. So we want this to be looking at one part of the process or the other one. So again, here we have our vision shows it in a way that we see a complete picture. So this dynamization technique and continuous or periodic useful action technique will lead us to the solution. We performed the same experiment with the Altshuler matrix. And again, here this is to remind that we use the second and the fourth bipoles for that. So we selected that from Altshuler's matrices. Both these examples were included here and recommended without the matrix. And then here also I show examples of other recommendations which were proposed, which were put forward from the Altshuler matrix. The same we have here, this transfer, if you are not confident in bipolar techniques, bipolar approaches, then also we can use mono techniques, which bring us to similar solutions. We have many bipolar techniques out there, but also mono techniques can be used for that. Field introduction. When it comes to field introduction, there is such a way to solve this problem. Then it is recommended to use the line of development. Again, the line of the field itself, and then dynamization and structuring of the field is recommended when we make it close and actually make it work with those elements of the system. A few words on conclusions. So this conclusion corresponds to what Simon has already mentioned. Trees is still developing, its development continues, and the most interesting thing is that a lot of forecasts or predictions of Mr. Altshuler from 1980s, they are coming true. This is about pair techniques and switching from techniques from principles to standards. But these are quite difficult actions in terms of research, requiring some skills. But anyway, this speaks for the fact that trees is still developing, and it's developing in the areas mentioned by Altschuler and in these areas about which he wrote. When we created comprehensive standards, we unified, we took different tools and use them to create to combine to use them in a combined way in the mechanism. We use functional analysis. We used individual techniques like typical conflict schemes. All this is then combined into a framework which otherwise would have been very complicated for application, but otherwise it can be a simple framework if we do that in the software suite.
Как раз 15 минут осталось, Михаил.
15 minutes are left, Mikhail. Well, indeed, this is the simplicity, which is like external, outward simplicity, which makes this simple to switch to other areas, adding development, lines of development, adding techniques and other elements. So this really happens here, and that is, it becomes even more simple, even simpler when we work with these structures. If we add AI techniques, technology here, of course, maybe we can go beyond that, and we can have like immense results, outputs out of that with the help of AI. This is what I wanted to tell you today. Is there any questions? Maybe Alexander, you could tell me if we had any questions in the chat box. In the chat, we had like a methodological discussion on bipolar analysis, on standards. There is a comment on why standards are not used, because they are complicated, they're complex. Yes, indeed, but we don't have any questions in the chat. Building on this comment, we are developing a framework where standards can be applied by AI, not by humans, while people get the output of this application. So this is what we're working on at the moment. There are a number of challenges here. Of course, people are lazy, and this laziness can be infinite. Building, drawing up a simple model is hard for them, and it's possible to understand, to use these technologies, these approaches to find a solution to problems. But we even try to spare people from the need to do that. When we have these mechanisms, which enable us to switch to transfer to typical conflicts, this might enable us to automatically switch to solution models proposed to users. So this is how this area is currently developing. Any questions or comments?
Михаил, вот
Mikhail,
глобальный
now
вопрос.
I have like a
Появится.
global
Где
question.
взять деньги?
The
Нет,
question is,
глобальный
where do
вопрос
we
о
get the
том, как
money
развить мышление
from?
человека.
No, the
Потому
question
что,
is how we
с моей
develop
точки
human
зрения,
thinking.
стандарты
In
гораздо
my opinion,
мощный,
standards
более мощный
is
инструмент,
a much
чем приемы и
stronger
так далее.
tools
Я
than
сам ими
techniques. I
пользуюсь уже
use
40
standards.
лет
I've been doing that for
и
40
знаю
years,
их
and I
эффективность.
know that they are
Но как
objective,
вот
but
заставить
how we
людей
can make
мыслить в
people
терминах
think in
биполярных
the terms
стандартов?
of bipolar standards? How can we do that?
Значит, узок круг людей,
We have a
которые
limited
готовы мыслить с
number
новой
of
алгоритмом.
people who are ready to
Ну,
think about standards, and
не знаю,
we
мы пока идем
are
двумя
still,
путями.
moving
Первое–
in two
это
directions. First
вытеснить
one is
человека из
we want to
процесса решения изобретательской
remove
деятельности.
humans
Мы
from
мешаем в
trees,
Да,
этом
да.
процессе.
from the
Он
trees process.
путается, он выбирает не ту конфликтующую
People
пару,
can
и
make
вообще
mistakes. They
мы
can
мешаем.
select wrong pairs.
Но это было
Sometimes,
бы
well,
очень
people
странно,
are not
значит,
good in this process. But on the other hand, it would be strange to do that because we remember the teachings of Altschuler on the one hand, yet on the other hand, practic-wise, in practice, like Alexander has already mentioned, at Rusal we have many smelters, many plants and mills. We have many people working at these smelters. Just recently, I've spoken to a specialist from our alumina division, and those working at Rusal understand the person who I'm talking about. And we are located in different time zones. There is a call to this person, and the person there tells him that there is an issue, but he has these standard solutions in his head, and he understands that whether a substance needs to be added, whether we need to do it or not. He already has it, and in 15 or 20 minutes, he finds the solution they need. But again, those solutions they have are very critical, whether you take a decision or otherwise your smelter is shut down, or it can lead to tragic events, or you find a solution to a problem to avoid that dreadful situation. So this again role of people is needed. So it cannot happen without a person, but we need to teach people and we want to motivate them. But according to the statistics we have, Anton Kulakov, maybe you can hear us. For every 1,000 people, maybe there are like 5 or 10 people which we can motivate. Yes, indeed, this is what we have. We had this survey at Rusal, so we had this survey inside Rusal. We made it a voluntary initiative. So we really need to find those crazy people who want to develop themselves. Building up on Valeri's question, Mikhail, no one says that standards are not good or inefficient. The challenge is that standards speak the language of bipolar analysis, which is the language which is purely artificial, and for many engineers, they cannot accept it. Many of them just cannot accept it, cannot stand it when you compare a loaf of bread and a car being called just a substance. So those possibilities of this functional and component parametric analysis overlap, and they actually outperform and beat bipolar or term models. If we want to save standards and enhance standards by means of using the language of functions, elements, which is good for engineers. I introduced my inventive standards system for business, which is purely based on the functional analysis. So you do perform the functional analysis of your system, finding the functions that are inefficient or which are not that efficient. So they do their homework. They find this good solution out of this. But then after that, they don't apply it, they don't use it. And I am struggling to understand why. Because this is not part of their thinking, of their mindset. The problem is not about bipolar analysis, but about this model thinking, model mindset. We have a lot of people who, looking at sand or aluminum, they do not see the generalization which you meant when you referred to analogies, when you spoke about analogies. There are these elements of models and generalization. This functional model, it does not contradict the engineering mindset, and it's possible to teach it to them in bipolar analysis. If you're telling us the 5 persons out of 1,000 can use it, while for functional analysis, it is much easier. All people who know how to do it, they do it, and engineers can do that. Well,
Да, вот
it's not
это
completely
интересно.
like that, and it's not like that completely, you know. I think maybe you will support me on that. Looking at and speaking of this engineering language, they start formulating functions in the wrong way, and this might impact that one. So using this model approach, then this might work much better. We need to start. This is what I have already told you. We need to start from the functional analysis followed by parametric analysis. Yes, Simon. Yes, this is a simple transfer which you as just demonstrated when it comes to Valeri's question. For many engineers, this proves to be very difficult for the recent years. In recent years, I've been training businessmen, many businessmen, and I see the same problem when we have this very simple switch from a model to a solution, which, you know, causes this psychological discomfort in these people. This is what concerns me, and they come back to the matrix. They get back to the matrix. Yes, we have already had such a discussion. Now, colleagues, of course, AI is what we all understand. I see that models can work there. We can integrate models in prompts, and AI can understand that, while it also can speak with users in their language. So this is one of the areas which is possible. Some happy news. Our students at the trees tournament are doing well with this switch. They don't have this psychological inertia. They don't have it. Yes, no, they don't. This is how they were taught to do that, and we don't know how they behave beyond the classes. Valerie is telling that they can work very well with problems at in classes, but then in practice they do nothing. They don't implement it. So they have the knowledge, but they don't have the skill. We always remember Altshuler. We discussed had a lot of discussions on that with him because we have this thinking with those algorithms or recommendations or models, which Mikhail you have just mentioned. So this procedure when you speak of some unreal objects, there is a big gap between those algorithm steps and models, and further this step you need to make. In my opinion, the development of imaginative, creative thinking still plays a great role. People are afraid to do that. They have a model, but how to switch from a model to a real change? And here we have this emptiness or gap. Yes, indeed. You are right. This is right. I think we don't have any more questions. Now, maybe we can call it a day.